In this tutorial, we will be discussing physical and chemical changes. A physical property is one that a substance displays without changing its composition. A chemical property is one that a substance displays only through changing its composition. For instance, if we look at gasoline, the characteristic odor of gasoline is a physical property. Gasoline does not change its composition when it exhibits this odor. The flammability of gasoline, however, is a chemical property. Gasoline does change its composition when it burns. Another example of a physical property is the boiling point of water. Boiling is a physical change. It's going from a liquid to a gas. When water boils, it turns into a gas. But the water molecules are the same as both the liquid water and the gaseous steam. Whereas a chemical property, for example, the susceptibility of iron to rust. Rusting is a chemical change. When iron rusts, it turns into iron oxide. Notice that the chemical makeup has now changed. Therefore, this is a chemical property. Matter undergoes a chemical change when it undergoes a chemical reaction. In a chemical reaction, the substance present before the chemical change are called the reactants. Then the chemical change occurs, which is the arrow, and the substance afterwards is called the products. In this process, matter is neither created nor destroyed. In chemical reactions, the changes in mass are so small that they can be ignored. During physical and chemical changes, the total amount of matter remains constant. For instance, if we mix barium chloride with copper sulfate, notice here we tip the flask upside down and the chemicals are allowed to mix together. Even though a chemical reaction has occurred and precipitate is formed, the actual mass before and after remain the same. Here's another example. Suppose we burn 58 grams of butane in a lighter, reacted with 208 grams of oxygen in the process. Afterwards, 176 grams of carbon dioxide and 90 grams of water were produced. Either way, you had 266 grams at the beginning and 266 grams at the end. That's because the atoms didn't disappear, they just changed forms. They changed who it was bonded with. The difference between physical and chemical changes is seen at a molecular and atomic level. In physical changes, the atoms that compose of the matter do not change their fundamental associations. So in other words, during physical changes, whatever it's bonded to will still be bonded to at the very end. It's still considered the same thing, even though the matter may look different. In a chemical change, atoms do change their fundamental associations, resulting in a matter with a new identity. A physical change results in different form of the same substance, whereas a chemical change results in a completely new substance. Here's another example. If you push the button on a lighter without turning the flint, the liquid butane, which is in here, vaporizes into gaseous butane. It's still butane. The liquid butane and the gaseous butane are both composed of butane molecules. This is a physical change going from a liquid to a gas. However, if you push the button and turn the flint, creating a spark, it produces a flame. The butane molecules react with the oxygen molecules in the air to form new molecules, carbon dioxide and water. This is a chemical change because they're bonded to different things now. Here's an example of a physical change to separate mixtures. It's called distillation. We have two liquids in here that are mixed together. We can boil this flask, and using the differences in boiling points, we can separate out the mixture, because the one that's going to boil first is going to turn into a gas, and then this cold water here will turn it back into a liquid, cooling it back down, and it drips into a new flask. The one with the higher boiling point, the one that takes more time for it to boil, is still in that flask, the initial flask. Here's another example of how mixtures can be separated through physical changes. This is filtration. This is to separate out a solid from a liquid. Here we have filter paper, just as if you were making coffee and you have filter paper in the coffee. The filter paper keeps the grinds of the coffee out of the solution that you want to drink. This is what this is doing in the lab. It's keeping the solids out of the solution at the very end. But as a reminder, never drink anything in lab. I was just using that as an example. So let's go through and try to identify things as either physical or chemical changes. What you want to ask yourself is, A, is it the same thing when it's all done? And B, can you easily change it back? Ice melting. Ice melting means it's going from a solid to a liquid. Can you make it go from a liquid to a solid very easily? That would be yes. That would be physical. Boiling an egg. Can you unboil an egg when it's all done? The answer is no. Therefore, that's chemical. Baking a cake. Can you unbake a cake? No, that's chemical. Wood is being chopped, the wood itself. It's still wood, it's just smaller pieces of wood. Therefore, it's physical. Wood being chopped, and it's the person who's actually chopping it. Well, he's burning energy. Therefore, it's chemical. You can't get that energy back. You have to consume more food to get energy. When two clear liquids are combined to produce purple in an unexpected color change. They're both clear to begin with, so in order to make that purple color, the atoms had to rearrange to make that happen. I threw that one in there so that way when you're in the lab, you realize that when you see a color change, that's a chemical reaction. As long as it's unexpected color change. And when I say unexpected, I mean if you put blue and yellow together, you know you're going to make green. But if you put clear and clear together, you don't necessarily expect to see purple. So it's unexpected. Water and Alka-Seltzer are mixed, creating bubbles. Those bubbles are actually a physical change because of the fact that they're separating out. The carbon dioxide was stuck in the molecules, just like putting Mentos in soda. Slicing bread. It's still bread at the beginning and at the end, so therefore it's physical. It's just smaller pieces of bread. And finally, rusting a nail. We had this example earlier. It's gone through a chemical change because you cannot unrust a nail. It's now rust. It's no longer considered the original composition. And that is physical and chemical changes.